Hi, welcome to the Linux channel. So this video is sponsored by Linode. Linode provides virtual servers which are easy and affordable for you to host anything in the cloud. So get started with Linode today and get $100 free in credit. Check the links in the video description. Support this channel, Linux channel. So let's get to the show. Hi, welcome to the Linux channel. So quite often the times in a couple of episodes I mentioned that sometimes I don't use kernel modules, and I have a complete different approach to that. So this video I am going to show that one such little dirty secret which I generally use, tend to do quite often. Before that, a big disclaimer that I would like to mention that see, this is meant for somebody who is already well aware of kernel software development. If you are a beginner, perhaps you can take this point, but I highly discourage approaching something like this, because you have to do this unless you know what exactly you are meant to do, and you know the other consequences. Okay, because if you do any mistakes, then it can give undesirable effects. Okay, and moreover, you cannot do something like this and make a public version of open source kernel patch and try to submit it to the mainline kernel team. Obviously they are going to scold you, and the gatekeepers will never accept an approach like this. So it is strictly against the ethics of or guidelines of the kernel source code contribution. But on the other hand, if you are doing it for your own projects, it is something, an open source project which is completely owned by you, done for you, for your own fulfillment, then definitely you can try something like this. So I'm just going to show. See, most of the times when you do a kernel module, you are going to initialize, you are going to also allocate any resources. This is the whole objective of the module init part. So most of the times you will do some driver, you will initialize, you are also going to do malloc and allot resources, allocate resources, and stuff like that. So as a reference, I am going to quickly walk through my old Toffee code and show that how I approach. So you can see over here, this is the kernel source. This is quite old. It is based on 4.8, as you can see here. So if you come here in the init, you have this main.c, just like you have user space main of API or the function, like that kernel has this main.c. So if you open this, you can see this is the source code of main.c. You can, of course, if you are interested, go here and you can navigate the kernel source of more recent kernel or the latest current release. So you can go there and you can see there init, and you get this main.c. So obviously if it is a newer version, you will have lot many lines and different APIs which may differ versus my version over here. Hence I am saying, if you are attempting it on a different version, you have to use some common sense and so that you don't do something inappropriate, so that you get a kernel crash. Okay, so you can see here it is initializing all these subsystems or routines. So by this way, kernel is actually preparing all the helper modules or subsystems of the kernel itself. Okay, so you can see the init of so stuff, and finally somewhere here the main this thing ends. See, this API starts at you can see there start kernel. Okay, so this is the main big API which is part of this main.c inside the init folder. So you can come here, it is doing all the subsystems, and finally it is going to end. So somewhere here you can put your API, and then you can create your own init API, and this is nowhere a kernel module at all. Okay, I will also tell you the reason why I do like this also, although it's a dirty way to do this. Okay, so you can see there after all this init, this API ends. So somewhere you can hook your API. So I'm going to show you my code, and then we can discuss further. So come back here and I can search directly the word say toffee, and we can hop on where and all I have inserted my code. You can see there somewhere in this, includes, I have included a couple of header files of my toffee code, and of course as you do, if required you can also add somewhere here. Okay, so that's what I'm doing. Again I search, the next hook is somewhere here, as you see here, ftrans init. So something like this I have added my init API. So this if you do, you no longer need a module init, module exit, because it is actually not a module also. This is why I keep saying kernel development is not about writing modules. You can also do serious kernel development without modules as well. So the best example is this. But again, I'm saying if you are a beginner, you just avoid this logic. If you are good enough and done some considerable R&D and done some development, then you can take some input. Okay, so you see there, so the position of this hook is quite important. I mean the API where I'm adding. So if you add somewhere here, let's imagine there is some subsystem which you need it inside your init. So let's imagine the subsystem itself is not initialized. Then what will happen? Your init is not going to work properly, and it may create any kernel crash or something. So use some common sense, wait some time so that everything is ready, the kernel is somewhat ready, and then you can add your init, and provided you can put some nominal code inside that init, and it is going to work perfectly fine 95% of the times, because this I have done multiple times very often. Let it be toffee or let it be the current thing what I am working, I do this method all the time to avoid a module independent kernel modules. As I said, I am going to tell later why I tend to avoid making kernel modules. Okay, so you see there toffee init, that's what it stands for, tf underscore init. So if I search where the hell is this API which is implemented, is inside the net toffee folder. So let's go net toffee, and in this init.c I can find that toffee init. As you see here in this API, I'm doing a big kmalloc of a very big chunk of buffer allocation, and after that I'm setting all these pointers at various locations. So this gives a advantage, so that I don't allocate each pointer or buffer independently. Instead I'm just taking a huge buffer and just keep allocating various pointers at various locations, so that all the stuff lies at a single location at a contiguous space, okay, as much as possible. So that's the intention, although internally it may not happen, but that's what is the intention, so that I do a huge allocation at a time and then set all these independent pointers. So let's not go inside internally what I'm exactly trying to do. The idea is I'm doing a very big malloc, and as you see here, I'm doing a malloc inside this init. After that, if you see that init also has a proc component which is also added in that init API. So you can see there is another hook which is actually doing this proc file init. So what is this tf init proc is? Inside this proc.c you can see the implementation of that proc code. So this is how a real code looks like. Especially I get this confusion from beginners. So they always see some 10 line of code, and they just don't understand the scale of a real production code. So if you are a beginner, just try to understand whatever you see in the internet is like a baby's code. Actually it's just going to contain some 10 lines, 20 lines, but here I am showing you a code which I have written, which is around 3000 or 4000 lines of code, and it is pretty huge. Okay, right now the size of the code is somewhat reduced because there are many components I taken out and made some changes in the architecture, hence the code has reduced in size. Otherwise it's very huge code. Okay, so you can see that the tf proc init is over here, and I'm doing this proc file create and all stuff like that. So this is quite often you find always if you have watched my proc file creation, I must have done a module in it, and also that is a code meant for small babies. Okay, this is how a real kernel code is. Okay, so you can see I can even open my article proc interface and the recent sysfs interface. Even this same technique you can do for sysfs, you can do for any sort of driver initialization. any kind of code most of the times without making as a kernel module. Okay, so you can see there, this is the proc code, and this is a very sample small sample code I have given. In this case I am registering this proc file and I am doing a file with read fops or file operations, and as you see here I am putting this hook inside this module in it, and in module exit I am doing is cleanup of that file. So it removes whenever you do rm mod of that module, then it will remove this proc file, or it will uninitialize and it will free up that resources or unallocate those resources. So this is what, as you see, the more heart of the code is hardly some few lines actually and the most important code, as you see, it is just hardly here some couple of lines, here some couple of lines. It is hardly around 10 line of 10 lines of code is over here. So this is a code meant for small budding kernel developers. It is a small baby step and it is a small baby's code actually, but in reality this is not the code which you deal often. As you see in the proc, there is lot it is going on, and if you scroll up, there is a lot I do here, and as you see, it is each time it is also calling various other APIs internally. So it is quite complicated, and the whole proc code itself is around 450 lines or so actually. But again, this is again a compacted code which is refined over many years actually. The whole Toffee project I actively worked around 8 to 10 years, so it is very much a refined code. Although right now I don't anymore work on kernel layer, I have moved everything to user space, but I am generally saying that. Of course, sometimes I don't work for some months or years together, and again I start working on the Toffee project. So again, currently I am not working actively, but this is how it is. Okay, so you can see I am doing this proc create and all. It is same like the test code what you see. I am doing this I am creating a directory and I am creating this files with so and so permission and all this fops, and in this fops I am saying that which is the APIs for read and which is the API for write, and here is this API implementation. When you do a read, what it should be done, when you do a read of that specific proc file, what it should be done. So we go back to this init. So one of the components is proc. Apart from that, I am doing some lossless compression, and also I need to initialize a lot of buffers for that compression algorithms, and also there are a lot of other buffers to allow how to say I cannot call multi-processing, multi-threading, because neither it does actually. I need to somewhat parallelize this my van-opt stack packet processing, so to a certain degree. Hence I am allocating some couple of how to say, some couple of instances of that data structure. Within the data structure I have all these buffers, so that it can parallelize and it can sort of process these packets as the way it comes into the networking subsystem. Okay, hence you can see again here I am allocating huge buffers here. So you can see LZ4 HC mem compress, this is a part of this algorithm. If you use that LZ4 high compression, then you need to use this buffer, or LZ4 then you use this buffer. And also you can see I am coupling this with this if defs, because if you enable in make menu config these features, then only this will be compiled. So it is a on demand compilation. So you can see that this is all it is done, and with this the init is over. Okay, so this way main calls this, and the most important thing is you need to find this sweet spot so that you don't put somewhere down. Sometimes you may get issues. You don't put somewhere up, again you will find issues, because the kernel boot itself is not ready yet for that things to be done inside this init. Okay, and again, as I said, we need to keep our expectations low in the module in the init. If you do something very extensive, sometimes it may not be yet ready. Okay, so use some common sense that kernel is still in the process of initializing and preparing itself, and somewhere we put our init code here. Okay, so hope you got. This way you can actually do a init code of yours inside a kernel code without doing a module, kernel module programming. So the drawback is, if you want to compile this, of course it is a very much an integral part of the kernel. You need to compile the whole kernel. There is no business of compiling the module alone. So it is very much a part of an entire kernel build. Then this code will get compiled and you will get as a part of the whole kernel build. Yes, sometimes you want to debug, you cannot do rm mode and then compile it, recompile it, do some changes, debug, prints, everything, and you cannot compile, do ins mod, and these cycles you cannot do. Okay, you need to once again compile the whole kernel and you need to do that. So now comes the part why I don't like kernel modules. See, when I had a company long back, I had my own company called Double Fish Solutions, and I was offering the toffee at that point of time I used to call as Trophy Squeezer as a paid support and this thing. So one of the drawbacks is, if you have kernel modules, okay, you need to have some method of invoking this kernel modules after the kernel boots. Okay, so the problem is, these are like these are like supplementary kernel modules. These are not drivers or anything. Okay, now you have a challenge that kernel boots. After that you need to do an insmod of this. Perhaps you need to put rc local or somewhere or some daemon in user space. It kickstarts and then it will load all these kernel modules and then prepares the system. So as a CEO in me, I don't like this approach at all. Okay, something broken up I just don't like at all. And one more issue is, if you manage in kernel modules, sometimes some of the code what I have is also there in other parts of the kernel. There are some code here, there in IPv4 stack, in bridge stack and stuff like that. Now who will support? So anyway I need a custom kernel and a custom kernel module which fits only with that kernel. Okay, so the problem is, by mistake, if the customer takes this kernel module, in case he self compiles and he tries to put on some other Ubuntu or Fedora system, at that point I used to do for Fedora as a reference OS. Nowadays I shifted to Ubuntu. Okay, so let's imagine customer installs a Fedora OS or CentOS in a server and then takes this kernel module and tries to insmod in that accidentally. Then it is going to throw up errors because the kernel module is not compatible with that kernel version which he had booted. And so this is the thing, I don't like generally a developer approach. As a CEO, I want to give as a full-fledged product. You make a single kernel build where it contains all these components jam packed. Okay, so that it doesn't come as kernel modules. And okay, so I'm again saying, see, you don't next comment me saying that this is something I don't agree and stuff. I'm saying it's just the way sometimes I do. It's a dirty trick. If you are interested, you can explore something like this, and it's a very good approach to completely avoid doing all that broken kernel module stuff, because the problem you need to deal is in the runtime. Again, you need to do insmod and stuff like that, and we just don't know whether it works or not. This is another issue which I generally don't like about kernel modules, is whenever you install something in runtime, let's suppose it has some inconsistency or something like that, we just never know. It only gets apparent when you do an insmod. Hence this again as a this thing, as a solutions architect, I generally don't like, because all these unknowns are solved when you compile the kernel itself. When we compile the kernel itself, we are getting something all put together, and if you get a successful compilation, it itself is a proof that you got everything put together, all in place, and everything fits well. Okay, and you don't have any other further unknowns during runtime. Of course, code can contain any runtime bugs and it can crash and stuff like that. I'm not denying that, but I'm saying syntactic or some of the things are solved because you have done the whole compilation and the whole kernel stays monolithic in one this thing. So hence this is a quick way you can actually do kernel development without kernel modules. And in fact, this whole init itself, you can fit this whole proc code itself. If you see, take my old link I'm going to attach this proc code and also this sysfs which I have done recently. Sysfs, yeah, Linux channel. Yeah, this episode which I have done recently, you can take this. So both of them almost you can fit as a single file, and you can invoke in the main.c of start kernel API. Okay, so it is again, as I said, this is an approach which you can't just do something and then submit your code to the kernel team. You should never ever do this way, and in my case I'm never interested submitting my traffic squeezer code or toffee code to the mainline kernel either. Okay, but as an open source project I always released my source code, okay, as per the way GPL v2 license dictates. But having said that, there is no rule saying that I need to submit to the mainline kernel. Okay, I can keep it with me. Yes, I can get some advantages if it is mainline compatible, and compliant, but I'm not interested, because you need to again change lot more things to make it, to please the jury. Okay, so I'm fine with the approach what I do, because I'm running a business there. I'm more interested in terms of catering the customer. So I'm not saying this is the right way or that is the wrong way. This is what my priorities are at that point of time. I'm more focused towards the product rather than pleasing everyone, and try to make this mainline compatible and try to submit it kernel gatekeepers and get it in the mainline and stuff. So hence I'm saying, if you don't have such obligations, so definitely you can try something, and of course you can break the rules, and of course it will still tend to work. So hope this video is useful as well insightful. So if you have any tips like this, you can share across. You can post your queries in YouTube comments, or if you want to discuss anything in private, be in touch via mail or in WhatsApp or in LinkedIn. So thanks a lot for joining this video. Stay tuned. Have a nice day. Bye bye.